Okay. So, once again, we're dealing with negative exponents. We know how it's negative, right? The exponent's negative. There's a negative sign in front of it, right?
Yeah.
Okay. All we're doing is converting this to a fraction. We're taking 10, 3, putting it down, no negative. Now when we get through the math, you'll start to see this. So, anytime you have a negative, anytime, no matter what the number is or whatever, turn it to a fraction. Is that clear? Okay. So once you turn it to the fraction, then we can actually do the math behind it. Okay? 10 times 10 is 100, times 10 is 1,000. We don't do anything with the 1 because there's nothing to multiply, right? Now, if it were, even if it were a fraction, it would change the problem. But we're not there yet. I don't want to go there. So, do we understand what we're doing here?
Yeah.
Negative exponent, turn it to what?
Fraction.
Very good. A fraction. Well, yes, it's still positive because what happens is when we move this to the fraction, it gets rid of the negative.
Yeah.
So essentially what you want to think, Daisy, is the bottom, this really is negative down here, and up here is positive. And so us moving it down gets rid of the negative. Are we clear? Okay, I'm going to fast forward real quick. Oh boy.
That's a lot of numbers.
Okay, we'll get there. Oh boy.
Don't go there yet.
I'm going to fast forward, we're going to go in detail. All this means is I'm moving this down here. If this is negative, all this means is I'm moving up there.
That was too fast.
It was. It was. I'm just trying to give you a teaser here that this is actually fun. This I'm taking it far. Okay, let's go to the next one.
Yeah, let's not.
Yeah, so 2 to negative 3. Same thing. 1 over 10 to the third, 1 over 2 to the third, right? Gets rid of the negative, that's 2 to the third power. Are we clear?
Oh, so you're just putting a 1 on the top of it?
Correct. I'm turning it to a fraction.
So whatever the number is on the thing, you're just turning it to a fraction and putting a 1.
Do we remember what this is called?
No. The power? No, that's the
Denominator.
That's the power. What's this called?
Denominator.
No,
it's a, what the fuck is it?
Fudge. Fudge. Fudge.
I want fudge.
The root? No, no. That's
Keep going, keep going, keep going. Starts with a B.
Hold on.
I don't know.
I'm
looking.
looking.
Oh,
I'm looking.
Language. Language.
I'm looking. Wait.
He's looking at the algebra.
Oh, it's there. It's there.
I'm looking. Wait.
So it's a
wait.
B.
You said it starts with a B. Base.
Amazing.
Wow.
Flip. I should have thought of
Yes, it's the base. It's the large number. And that's the power. Oh, I'm so happy.
You got it.
that.
Okay. So, turn to a fraction. Go ahead and do the math. 2 times 2 is 4. Times 2 is 8. Remember, this isn't
My ears are cold.
2
come
times
on.
2 times 2. Yeah, I'm recording the lecture, Adrian.
I don't even have it on though.
Just stop. Thank you. Thank you. 2 times 2 is 4. Times 2 is 8. It becomes 1/8. So, all this is 1/8.
Do we have to do the multiplication on the bottom every time?
It is a step.
Yeah.
If you show me the step and you make a mistake, I can figure out what it is.
Okay.
If you don't show me this, I have no clue where you made the mistake.
Oh. Okay.
So it is kind of important.
Okay.
Okay, good question now. Okay,
Okay.
this one's a little different. This one has parentheses in it, okay? So there's parentheses and negative 4.
Don't you just have to put in parentheses the entire time?
Yes, but we're going to talk about this for a minute.
Okay.
So we're doing the same thing. This base in parentheses doesn't change our rule, okay? We just take this base that's in the parentheses, write it down here, but the 4 gets rid of this. So notice, the exponent goes from negative to positive, negative to positive. That rule never changes.
But
Okay.
negative 3 doesn't go to a positive?
Correct, and let me explain why.
Okay.
What this means here is this is negative 3 times negative 3. The answer times negative 3. The answer times negative 3. Why is that important? That's important because it determines whether it's negative or it's positive. Are we clear? So let's go through it. Negative 3 times negative 3 is positive 9. So this is positive 9.
Okay.
Okay? Times negative 3, negative 27.
Okay.
Times negative 3, positive 81.
Oh, because the positive.
A negative times a negative equals a positive.
Very good. Very good. And that's why when this is all said and done, it's 1 over 81. Okay? But the way to properly write it out, we cannot get rid of these parentheses because these parentheses mean something. Now, I'm going to fast forward a little bit. Pretty soon, we're going to have numbers, we're going to have exponents, we're going to have parentheses, we're going to have more exponents, we're going to have a bracket, and we're going to have more exponents.
That's confusing. Don't do that.
We will get there and we'll understand it. It's all rules. So the first rule, negative exponent, turn it to a fraction.
Okay.
Okay? Multiply it out, get your answer. This and this are the same thing. Okay? But this is simplified, this is not.
Okay.
Okay? Are we good? Are we good with this one?
Yeah.
Okay.
What is that circle on the top?
We're going to talk about it.
Oh,
Zero.
It's a 0.
oh.
So we understand negative fraction, multiply it out, turn it to fraction, we're finished, right? Let me see thumbs up or down. Good. Okay. This one is kind of fun, and let me explain. If you have a 0 exponent, is that something that even exists?
No.
It does.
Really?
It does. It
How?
does. But let me tell you what it means.
Wait. So is it like the number line? So like whenever you have a negative, you get a positive, and you have a zero in the middle.
No.
Oh.
I like your thinking now.
Okay.
This is what this means, okay?
You lost me.
It's really, really easy if you hear this when I say it. Anything to the 0 power is 1. Even if it's a million. Even if it's a fraction. Even if it's a decimal. Even though it's a really large number, it's always 1.
What if it's a letter?
Depends what the letter is, if you're being told what the letter is. Good question. So let's say it's A. You know what? The answer is it doesn't matter, right? Because it doesn't matter what that number is. If we say A to the power of 0, and we say A is 4, it's still 1. If we say A is -7, it's still 1.
It's the one.
Yes. And you'll see this as we get through these problems.
So no matter what, whatever, if it isn't the exponent is a 0, we get 1 no matter what.
Very good. That's
Oh,
correct.
So it's like whenever you multiply 0, it's always 0.
Correct. It's one of these rules that never change. So here's the verbiage. Any non-zero raised to the 0 power is 1. So anytime you see this, you're not concerned with this, the answer is 1.
Okay, that phrase just confused the heck out of me.
Powers are raises. So in other words, 2
Yeah.
raised to the exponent of -3. We use it, well, and right, we have small, what's this, the small one is what above the number, is a way to remember it. It's not lowered, right? It's raised, okay, good.
Okay.
All this new stuff we're learning, it's awesome. Yes, Adrian, go.
How is the D, how is that one fun?
You're gonna see in a minute.
I'm
I'm
not
too
very
technical, maybe.
Don't be. It is new, but you're gonna get enough practice. Okay, are we good with this?
Yes.
Doesn't matter what the number is, if the power is 0, the answer is 1. Simplified, 0 to the power is 1. 7 to the power of 0, 1. 9 to the power of 0, 1. Are we clear?
Yes.
Okay, let's go on this next one. Now, -3 over -4.
Wait, how does that turn into a positive?
I'll explain. So remember how this negative turns it down to a fraction?
Yeah.
Yes.
Okay, so this is what happens in this case. This -3, we know the number is going to be negative. Okay? So we write negative and we carry the negative all the way through. You can ignore the negative. It's not negative times a negative. The only time it's negative times negative if there's parentheses.
Wait, why?
Because this means a negative times a negative. All this means is -3 to the power of -4. So I know this right here, all you need to remember is if you have a negative on this outside, your answer is negative. No ands, ifs, or buts about it. Doesn't matter what the power is. Doesn't matter.
I just.
It's just a rule. Okay, parentheses. This is a negative times a negative. That's the only time it happens. Okay? If this is not here, look, aren't these the same thing?
Yes.
They're the same
The
thing.
whole thing's exactly the same.
There's only one difference. You see this negative on the outside?
Yeah. Oh, so like you're doing the whole.
So you carry the negative throughout the whole entire problem.
Yes.
So all.
So you can ignore it, right?
Yeah.
This becomes negative, that's negative, that's negative. If there's a negative there, your answer's negative, no matter what. Okay? This is when you have to pay attention to a
Okay.
negative times a negative. Only in the parentheses, that's it.
Everybody's gonna struggle on this on Monday.
One more time?
No.
Okay, we're good? Okay, so once again, the same stuff, right? 3 to the 4th power, raised to the 4th power. 3 times 3 is what? 9 times 3? 27 times 3? 81, okay? We just take this negative, carry it all the way over. Any questions on this one?
So if it's not in parentheses, it's gonna be negative throughout the whole time?
Yes. This is like an identifying factor, it doesn't change. It's negative in the end. Simplified, okay? So that's why you kind of like negatives, because you know you don't have to think that way. The only time you have to think that way is if there's parentheses. Are we good?
We got you.
Okay.
Okay, now we're going to start to solve them.
Are we having fun now or no?
Yes, we're getting there.
Oh.
Okay, ready?
Yes, sir.
Yeah.
X raised to the power of -1, x is 2. So you remember what this means? This just means plug this in, right? Substitute 2 for x. So that's what we're going to do. 2 to -1. So I took the x and replaced it with 2.
Oh, so that's like
This colon is saying, what this problem is saying, it's saying x raised to the power of -1. What is your answer if the power is 2? Now notice, if we don't know this, we can't solve this, because we have no idea what's going on with that.
So does it always have the what x or the letter equals to?
Yes. If you see this, it's always going to be telling you something. Where'd it go? Is that the only one I gave you? Apparently that's the only. Yes. So anytime you have this as saying x is 2, you just have to substitute it in. Okay, so we put it in, we rewrite the problem with the 2 in here. This is all the same stuff, okay? So this 2 goes down at the bottom, there's a 1 there. Well, what's anything to the power of 1? Itself, right? So this is just 1/2. So that's simplified as 1/2. Okay? All right, let's move on.
That a right there, it would just be a 1. So it doesn't matter what.
Yep, we'll get there. We'll get there. So this one's just like this one. This is saying a to the power of 0. B raised to -3, a equals 8, b equals -2.
Can I go down the
Can you wait just a few, please?
No, I have to go to the office.
Okay, just wait until I get through this, please.
No, I have to go to the office. I'm gonna come back. It's just real quick.
But I want to get through this.
It's just real quick.
Okay, so a to the power of 0 and b to -3, or raised to the exponent of -3. B is 8, a is 8, b is -2. So we're going to substitute this in, okay? So we're going to replace, I can't talk today, replace a with 8, and we're going to replace b with -2. Now notice, b goes inside parentheses.
But why?
I'm going to explain.
Okay.
What is a variable next to a variable mean?
Multiply?
Yeah, very good. What does this mean?
Divide.
What does this mean? Or this, right? Or this. There's multiple ways to write it. But the way that we write it is like this. Okay, we use the parentheses to simplify what type of math we need to do. Okay, so let's move forward with that. So that means is b, -2, inside parentheses. Well, remember what I said about the parentheses?
Yeah.
Okay, so let's go ahead and work through this. What's a to the power of 0?
1.
Right. So that part doesn't even matter, does it?
No.
We already took care of that. That doesn't matter. We can leave it alone. Now we got to deal with this one, right?
Okay.
So we're going to turn this one into a fraction. 1 over -2 in parentheses raised to -3. Oh, did anyone see something I did? Possibly?
Oh, I see.
Where? Tell me. Yes! Good. Good.
I didn't see that negative
If
Get
that,
new glasses.
there. I have to.
I accidentally wrote negative. Remember what I told you is that when we have it like this, it goes like this and negative goes away. Because here's the thing. If that were -3, we'd have to move it back to the top. But we'll get there. Okay, so we're a, -2 in parentheses, -3 is what it's raised to. So we put 1, we know this is all 1, so 1 times 1 at the top, -2 into parentheses to the 3rd power. Okay, so now we can start solving this. By the way, does this 1 even matter?
No.
No, because it's times itself, right?
Yes.
Has no bearing on the problem. That's why we like the power of 0. Because it doesn't do anything to the problem. Right? Okay, good. So really this becomes just this.
Yeah.
Okay? So -2 times -2 is +4. Times -2 is -8. Okay? So this becomes 1 times the fraction of 1/8 with the negative at the bottom. Now this simplified +1 divided by -8 makes it -1/8. That 1 doesn't even matter. We're done with the problem. I'm sorry?
Why would the negative be on the bottom?
Because of this right here.
Okay.
Negative times a negative, +4, times -2, -8. This is not simplified, this is simplified. Because the 1 doesn't matter, and remember rise and run and that sort of thing?
Yeah.
And when you have a y, -2y, you divide it by that -2, and say it's it turns negative, right?
Yeah.
So that matters which one's negative and which one's positive as far as how we solve it. So at the end of the day, if this one's positive and this one's negative, we know it's going to be negative. What happens if this was a -1? It turns to +1/8, 1/8, because us simplifying that fraction, it's a negative by a negative. Now, I will tell you, that typically doesn't happen, because notice what happens in all these. The negative forces it to a fraction, the 1 is always going to be what it is, 1. Okay? So, do you kind of see that basically what we're doing is we're taking those negatives and we're forcing them down to denominators and we're solving the problems in the denominator form. Is that clear? Okay.
Yeah. No.
Okay. Okay, watch this. You see this?
Not for me.
Watch, you see this?
Yeah.
This comes down here. You see this? Comes down here. See this? Comes down here. We're forcing all this problem down to the denominator.
I know all that.
Okay.
There. You lost me that.
Here?
Yeah.
Okay. X is 2. I just rewrite the problem. 2, -1. Forces the 2 down to the denominator. Right? 1 is always at the top. 2 to 1, 1/2. We're done. Fairly easy problem. Okay, now this one. We have to substitute. We don't know what this is. Okay? Now, if these are letters, we can still solve for the letters, but we can only take it so far. That's what happens when we get down here. So we're saying 8 is 8 and b is -2, so we go ahead and write that. 8 to the power of 0, -2. So we're forcing all this down to the fraction. That's just 1. That stays by itself. It's just 1 because it's not a fraction. And then we multiply this out because it's in parentheses. -2 times -2, +4 times -2, -8. So we're 1 over 1, -8. Simplify, the 1 doesn't matter. Positive divided by negative, -1/8. Are we good? Okay.
I got the answer.
All right. Notice what's different in H. Go.
Okay, so there's the number, variable, and then
Oh, yeah.
next one was.
Yes. Okay. This is all you need to know when it comes to a number. Okay. The number ultimately, when it's all said and done, becomes the numerator. That's it. Okay. The number, the whole number, not a mixed number. Well, I guess it's a mixed number. It's the whole number of the mixed number, right? That becomes the numerator.
Oh, okay.
So let's cover this. 3 to y -2. Okay? We don't do anything with this 3, but what is this? What type of math is this right here?
Multiplication.
Multiplication. So 3 times y -2. We're not doing anything with the 3. We're taking the -2. We're putting it down in the fraction, maybe, with 1 at the top. So let's go through that slow one more time. We have a number. It needs multiply. So we're breaking this up. That way we can focus on this right here. Okay? So this is y. It's going down to the bottom with 1 at the top, right? We don't do anything with this 3. When we go to simplify it, 3 goes at the top. One more time. Number.
Wait, he is right? Yeah, where?
3y minus 2. Okay?
I get the second part. What about that? What is it over? Yeah. Why are you multiplying it?
Okay, the 3 we don't do anything with, right? The 3 stays by itself because it's a whole number.
Okay.
We're dealing with this right here. So we turn it down to a fraction. So this is this step right here.
Oh.
Okay?
Okay.
Do we see it?
Yeah.
So this y goes down at the bottom. The 1 goes to the top, and there's no negative, right, AJ?
Mhm.
Now from here, this part's easy. We just take the 3 and we put it on the top. Now why do we do that? I'll explain. Whole number goes to the top of the fraction. Okay? So this number is always your numerator. We already finished this. Okay? Because if this is 3 and this is 1 at the top and I multiply that, that's just 3, isn't it?
Yeah.
Yes.
So if it comes to an equation like that, most likely our denominator is going to be a variable.
Correct.
Alright. What?
Well, we're talking about denominators, so yes, if this variable is negative, it's going to become our denominator, yes. Just like the whole number is going to become our numerator, because what is anything times 1? Itself, right?
Yes.
So this 1 or this being this 3 is the same exact number. It's 3 times 1, which is 3. Are we good so far?
Yes.
Okay. I feel really bad because this is going to be a rough week. There's going to be a lot of people watching this video.
More likes for you, more views.
Okay.
Wait, Peter.
Yes, go.
When you first started, it's just turning with the fraction?
Yeah.
Without the negative?
Correct.
Alright.
Okay. Okay, let's go here now.
Okay.
Oh, jeez.
We have -4 as a numerator, and we have k -4 raised on the bottom. Now I want to show you something here.
So you're just doing the exact opposite of what we just did?
Correct.
Okay.
So let's talk about this. This -4, notice what we did, 3 here and 3 here. This -4 becomes the whole number. Because same thing here, right? 3 times 1 is 3. Reversed is 3, right? So if we have a number, this means this is the main number out. Okay? So we just take this number and we write it there. Then we have to deal with this, right? This is 1 over k -4. Now, notice, I didn't simplify this yet because essentially what I do is I get rid of the negative and write this over here. And the reason being is this at the bottom, reversed, is positive. Just like this goes to the bottom. So negative goes to the bottom, and if it's negative on the bottom, it goes to the top. Are we clear?
Yes, sir.
Except in a situation like this.
Oh, okay.
So, that's your number on the outside, that's the number that goes to the top. Okay? So, this end is going to the top, this one goes to the bottom, this is in simplified form. For us to get rid of this negative exponent, we write it on the top. So -4 times k4. Now, how can we write that? That's a constant next to a variable, we're done and we solved the problem. Okay? Yes? Okay, one more time. One more time. This is the main number out. Okay? If this is negative on the bottom, it needs to go on the top. So we write it out 1, k over 4. The way we simplify and get rid of this is it gets rid of the 1, because we wouldn't write it this way. But essentially that's what's happening. We're moving it, if it's negative here, we're moving it to the top. If it's negative here, we're moving it to the bottom. We're just flipping them. Make sense?
Yes, sir.
It'll make more sense when we get here, because you'll see it in letters and not in numbers. Okay, so we're done here because this means multiply. We can just put those together. It's constant to variable. So all of this simplified is this right here. Now, let me show you. Yes, the steps matter, okay? But essentially what happened, this became the whole number and this went right next to it.
So we're doing everything backwards.
Yes, everything backwards.
Okay.
All right, let's look at the next one.
Oh, that's good.
We have x to the power of 3. We have 9 to the power of 0, y to the power of 5. Okay? So, this is what we're doing. This x -3 goes on the bottom. This 9, 0 is just 1, right? Because anything 9 to the 0 is
One.
right. Now notice how this is not a -5, right? So this one stays at the bottom. Are we clear?
Yes.
So if it's negative, goes to the top. If it's negative on the top, goes to the bottom, right? If it's not, it stays. Okay? Okay, good. So this 1 doesn't matter, but let me tell you what happens here, okay? This x goes to the bottom. Didn't that move everything to the bottom?
Yeah.
Yes, because negatives go on the bottom, and these are all negatives now. Okay? Yes, go.
If all the numbers go on the bottom where the denominator is at, would it make it the equation more easier?
Ask me that one more time.
If all the numbers and everything like that, the variables and everything goes